Welcome dear students to our learning channel. So in this video I will be explaining how to compute or find the number of positive divisors of a given positive integer. For smaller numbers it is very easy to list out that divisors. For example, what are the positive divisors of 28? Second one, how many positive divisors are there for same number I'll take here 28. The thing is that divisors in sense, what are the numbers which are positive in nature? Here we are going to discuss only positive divisors only. What are the numbers that can divide 28 in the first case, and how many are there? How many numbers are there that can divide 28 perfectly? Divide in sense, the remainder must be 0 when you divide that number, whatever the given number. Here I took a small number, 28. So the idea will be clear to you. Later, what is the task? How to compute the number of positive divisors. Means second thing is most important, because what are the positive divisors? It is a time taking process. Only computer can generate those numbers. Here we are going to find out only the number, how many numbers are there that can divide 28. For 28, we can write like this: number of positive divisors of 28. It is our second question answer. First one, the divisors, I write in bracket positive for idea's sake. The positive divisors of same number 28. When you go back to the first one, we will write all the divisors, all the numbers, positive numbers that divide 28. It's very simple. 1 will come first. 1 will divide every number. 2 also divide. 3 won't divide. 4 will divide. 5 won't divide. 6 won't divide. 7, 14 into 2, 28. So 14 also divides. After 14, directly the last number is 28. Every number is divisible by itself. So what are the positive divisors of 28? You can list out like that. The number is very small. By thinking which table will be matching there, so we can write the number there. You see the second one, second answer. How many positive divisors are there for 28? Just you have to count the elements in this set: 1, 2, 3, 4, 5, 6. That's all. This we are going to find. Suppose the number is very large, 200, 300, 500, like that. This will take very time consuming method to list out all the divisors. And later on we have to count the number of positive divisors in that set. That number we are going to write here. So in this video, based on this counter example, we can have a formula to generate this number. Already in the previous video we covered fundamental theorem of arithmetic. With that theorem we applied to find out the GCD and also LCM. So here same idea we are going to use to compute or to find the number of positive divisors of a given positive integer, whatever it may be, how large it is, right? So based on that prime factorization technique we are going to find out. Let us see how it works, what is the formula and how to apply it. Let us see the easiest formula that can be applied. to find the number of positive divisors of a given positive integer. It may be a small number or a big number. Very simple to apply. Here we are going to make use of the fundamental theorem of arithmetic already discussed in the previous video. For example, step 1 in this task, express the given positive integer. I will take a capital N for time being as this. Already we know, we can write this one as product of distinct prime powers alpha 1. You can refer the previous video regarding this. Alpha 3. It is called prime factorization. P1, P2, P3 up to Pn, they are distinct primes. Alpha 1, alpha 2 up to alpha n, corresponding exponents of the prime numbers what we have selected there. Step 2, only 2-step procedure. The number of, as the task says, the number of positive divisors of capital N, this is the number given to you, is equal to, very simple, the powers only are going to help you. So we can write a shortcut formula first. I'll explain now. Capital Pi. Capital Pi indicates product of sequence of numbers. We write an index number here. I, you can take any letter, small letter, called index, running from 1 to small n. Right? Here we write alpha I means if y is equal to 1, alpha 1. If I is equal to alpha 2, the powers plus 1. If we expand, it is a compact formula to find the number of positive divisors of a given positive integer. Here n is a already mentioned positive integer. N is a positive integer. So substitute 1, we get alpha 1 plus 1. Because pi is there, we have to multiply. Next, take 2, alpha 2 plus 1. Again, multiplication. Take 3, alpha 3 plus 1. Up to last power, alpha n plus 1. This is a formula to compute number of positive divisors of a given positive integer. In the last video, before that explanation of this formula, I took example n equal to 28. N equal to 28. So step 1, we have to express n as product of prime powers which are distinct, which are different. This already you know, 28 we can write as prime powers. Try with 2, 14 times, 2 7 times. Of course, another prime number 7 1 times. Therefore, our 28 we can write as 2, the first prime number, it is appearing 2 times. Second prime number is 7, appears 1 time. So here what we observe is alpha 1 is equal to 2, alpha 2 is equal to 1 from this case under step 1. So step 2, what is step 2? Use this formula to get the count or number of divisors. So number of positive divisors of 28 is equal to, here only 2 powers are there, alpha 1 plus 1 into alpha 2 plus 1. So alpha 1 plus 1 into alpha 2 plus 1. So let us, I will be writing here in continuation of this, number of positive divisors of 28 is equal to alpha 1 is 2. We get here 2 plus 1 into 1 plus 1. This comes out to be 3 times 2, that is 6. Already in the previous example, for same example, there we listed out the divisors and then I counted the number. We got 6 there. Like that, you take any number, express the given number as product of distinct prime powers, identify what is alpha 1, alpha 2, alpha 3 and so on. To find the number of positive divisors of that number, just use this formula to get the count. Is the count. There are total 6 divisors are there for 28. Let us consider one more example to find the number of divisors of a given positive integer. So in step 1, what we have to do? We have to express n as product of distinct prime powers. So I am going to work out for you directly as it has been explained. 2 times, 4 times, 3 times. It will go with the prime number 3, again with 3, again with 3, again with 3, of course again with 3. So we can write capital N that is equal to 486. Here 2 is a prime number appearing only one time. 3 is a prime number appearing 1, 2, 3, 4, 5 times, which implies alpha 1 power of first prime number it is 1 and alpha 2 power of second prime number that is 5. Now number of step 2. In step 2, number of positive divisors of the given number n, what is nothing but 486. The formula, because only 2 powers are here, we have to take alpha 1 plus 1 times alpha 2 plus 1. Alpha 1 is 1 plus 1, alpha 2 is 5 plus 1. This comes out to be 2 times 6. Total 12 numbers are there that can divide 486. Here we are not going to list out those numbers, only the count is important. How to find the number of positive divisors for a given positive integer. It is just a simple example. Hope this video is clear to you and the examples are very clear to understand the concept, the usage of the formula. In next video, we are going to cover how to find the sum of the divisors. Sum, S-U-M, indicates. In the very first example, we have taken 28. There I listed out all the divisors in a set form. If you add all those numbers, what is the total we are going to get? For small numbers, easy to compute with simple addition. For large numbers, it is time taking process. So here we are how to find the total of all the divisors. For this problem, 12 are there. If you add all those 12 different numbers that are going to divide this 486, what will be the total or the sum is going to obtain? So there is a formula for that. Based on that same application, we can work out in next video. So subscribe our channel, share it to your friends. Don't forget to click the bell icon to receive the notifications. All the best.